Hello everyone, welcome back again to PLAXIS 3D Shallow Foundation course from theory to practice. This is lesson 49, and in this example we are going to simulate a shallow foundation on Geocell-Reinforced soil using PLAXIS 3D. So before I start modeling in PLAXIS, I will briefly talk about the geocells and application of geocells in geotechnical engineering. Geocells are 3D honeycomb structures and mostly or generally made from high density polyethylene and used for soil reinforcement and stabilization in geotechnical engineering application, as you can see in here. For example, they are used in pavement engineering or for slope stability and erosion. As I said, there are some application of geocells in geotechnical engineering, like reinforcing the soft and weak soils. Also for load distribution, enhancing the load bearing capacity for foundation and pavement, and also for erosion control, which prevent soil erosion on slopes and embankments. Actually, the geocells are generally used in, as I said, in pavement engineering or in erosion control for slope stability, but there are some laboratory and experimental about using geocells under the shallow foundation, or in another way, the foundation on geocell-reinforced soil. We have many research articles in the literature. So the general parameters of a geocell under the foundation are mostly similar as a geogrid, which we talked in detail in previous example. For example, as you can see in here, if you have a foundation and first the dimension of the geogrid, which is L or B small, it can be any dimension, and there are many research about the optimum dimensions of the geocells below the foundation, and most of them says that this dimension must be between 2 to 4 times greater than the dimension of the foundation. Also, the first layer of geogrid below the bottom of the foundation, which is U, and in most of the research articles it says it should be between the optimum U dimension is 0.1 to 0.3 times the dimension of the foundation, or the short dimension of the foundation. Also the height of the geogrids, so it can be 1 layer or 2 layer or more layers of geocell. It can be 1, 2 or more layers of geocells below the foundation. So in this example, we are going to use this dimension in PLAXIS 3D. Our soil contours will be 10 meters by 10 meter, and foundation is a square, which is 1 meter by 1 meter, and the geocell sheets are 3 meters by 3 meters. We will use these patterns of geocell, which is like triangular, and also the first we will use only 1 layer of geocells, and which is located 20 centimeter below the foundation, and also the height of geocell is also 20 centimeters, and we will use 1 single soil layer, which is a sandy soil, and 7 meter. After that, we have to proceed to structure and create a geogrid. So I proceed to here. For modeling the geogrids, I will import from the AutoCAD. So I have already prepared, for example, the shape of geograds can be like this one, or maybe a different shape. So it doesn't have a uniform or regular shape. This one can be drawn by these tools in AutoCAD. Also, maybe we can model like this one. So in this example, I will use this shape of geogrid. And also another point I want to mention, the center of this shape should be at 0, 0. It should be at the origin. So for example, if I click on the line and type 0, 0, as you can see in here, this is the center of these geogrid lines. So I will import this and it also should be in a DXF format. I will import these files into PLAXIS 3D. So I open here PLAXIS 3D and I click on import structure. So I have to save the project in lesson 49. I click on save. I think right now everything is okay. We can start the calculation and see the results, and we will check how Geocells, if we use Geocells under the foundation, how it affected the results of or how it can improve the settlement and building capacity of the foundation. So it may take a little bit long time because we have many surfaces in soil volume, which are the Geocells. Okay friends, after a long time the calculation is finished. We save the project again, and right now we can check the results. So I click on view calculation results. So as you can see, this is last construction phase when we have a Geocell under the foundation. As you can see, this deformed shape of geogrid under the foundation, and the maximum settlement is about 3.5 centimeters. So if we check the settlement in foundation on unreinforced soil, we can see we have about 6 centimeters settlement. So in this example, we just used one layer of Geocell, and with this dimension, which are 3 meters by 3 meters, and you can, for example, you can use maybe a larger dimension of the geogrid or smaller, or also you can use for example multiple layers of Geocells, maybe 2 layers, 3 layers, 4 layers, and you can check the results, how can it affect the settlement and bearing capacity of foundation. So if we check the deformation, we can see in here, and as you can see, this is the legends in case of Geocell-Reinforced soil, and also this one for unreinforced soil. We can also check the load displacement curve for both cases. So I click on Curves Manager and click on New. So in X direction we have the M stage, in Y direction we have the displacement in Z direction. I click OK and right click on the figure, and I will change in here for this one will be for unreinforced soil, and I will only leave the second construction phase, which is foundation on unreinforced soil. We can see this is a load displacement curve for the foundation on unreinforced soil. So I will also add another curve from the same project for the foundation on reinforced soil, or Geocell-Reinforced soil. So, and also I will just leave the last construction phase. As you can see, the red one is for unreinforced soil, and the blue one for unreinforced soil, and the red one for Geocell-Reinforced soil in this example. As we can see, also the settlement is decreased, and also the stiffness of the soil is increased, as we can see from the load displacement curve in red one. You can also increase the amount load in the Geocell-Reinforced soil and calculate again. For example, in here you can change the surface load maybe from 200 kilonewton per square meter maybe to 300 or 250, and check the results again. I will not export these curves to Excel, because you have done in a previous example. You can do it very easily. Also, I want to show you another thing. For example, I will click on deformation, total deformation, and if I hide the soil volume in foundation on Geocell-Reinforced soil, I will click on the select structure and press on Ctrl Shift and double click on one of the Geocells. So we can see this is a total displacement in Geocells. As we can see, the maximum displacement happens at the center of the Geocell. Also we can check the axial and shear forces as well in geocells. Okay friends, as I said, this one for this example, and maybe this shape of geogrid is not exact as in the practice, so you can draw any shape in AutoCAD and import it to the PLAXIS and do the same steps which we did in this example. I will also upload DXF files for two types of geogrid in the lesson 49, so you can practice them as well. Okay, thank you for watching. See you in the next lesson.